Alright, so if you had mates in the other class, they might have done Simpson's rule earlier, but I'm trying to do, I think I decided on a more sensible order so that you could start your DI a little early. So what is the Simpson's rule? I've given you formula for the area of regular shapes like rectangles, triangles, and circles. However, there exists a formula known as Simpson's rule that allows you to find the approximate area of any shape. It could look like a dot, right? It could look like anything. But there's a couple of rules that that shape has to follow for us to be able to use this rule. The shape needs to be divided into an even number of sections, all the same width. So I slice it into an even number of slices. And the lines I use to slice, they're also called offsets, used to divide the shape into sections. I need to know how long the lines were. So what are the two rules that's going to determine whether I can use Simpson's rule? I need to be able to cut the shape into an even number of pieces, and I need to know how long those cuts were. The formula is quite complex, as you can see over there, but if you use it with an example, it's actually fun. So, this is what Simpson's rule looks like. For any irregular shape that's divided into an even number of sections, all the same width, W, and we know the length of the lines used to divide the shape, with L0 being the left edge and Ln being the right edge, then my formula for the area is this: W over 3 times by L0, and then 4 times L1, 2 times L2, 4 times L3, 2 times L4, dot, dot, dot. What does the dot, dot, dots mean? Between the second and second last lengths that I know, I need to repeat 2, 4, 2, 4, 2, 4. Depends how long my irregular shape looks like, okay? And then the second to last length is always multiplied by 4, and then the last length isn't multiplied by anything. And you're looking at that like, what the heck, okay? This is one of those situations where when you run an example, it all sort of comes together. So I'll get onto the example straight away. Do you agree? Have I given you a formula for this shape? No, it's irregular, but has it been divided into an even number of slices? 1, 2, 3, 4, 5, 6. So even number of slices. That's the first step. The second step is, do we know that the widths are all the same? 18, 18, 18. Do we know the length of the lines used to slice? Well, my L0, I'm told, is 10. My L1, do I know what it is? My L2, do I know what it is? My L3? My L4? My L5? It doesn't tell me. But if it's coming to a point, how long is that? 0. So Ln, the last one, is 0 meters. So now, it should come a bit clearer how this formula works. Because the area is going to be, what is W? How wide are the slices? 18. Good. So the W is going to be 18 over 3, and it's going to be multiplied by a giant set of brackets that look ridiculous. But if you follow the rule, do I multiply L0 by anything? Is there a number in front of L0? No? So what is L0? 10 plus, what do we know? The second length is always times by 4. So it's going to be 4 times by, how long is the second one? 25 plus. Now what's this about with a dot, dot, dot? Between the second and second last lengths, you multiply by 2, by 4, by 2, by 4, by 2, by 4. I'm not going to do it very long here because there's only 6 sections. But can you imagine I might have to do 2, 4, 2, 4 if this was divided into like 20 sections, right? So the next one is going to be 2 times by, how long is this one here? 30 plus 4, so I'm repeating the 2 by 4 by 2 by 4. What's 4 going to be multiplied by? 38 plus 2 lots of? 36 plus, notice the second to last one is always going to be multiplied by 4 if you did it right. Plus 4 lots of, how long is the second to last one? 22 plus, do I multiply the last one by anything? What did we say the last one was? 0. So, yes, I agree that that's complex, right? But that's because I want to put down the steps bit by bit. But can you see how when I illustrated the example, that's what you apply, okay? I'll give you a bunch of time, so like 5 minutes. Can you get that and the example so far, and then I'll finish that off for you on the video. Huh? The rules on there are already on the right. So, yeah. What I'll do is I'll take photos of it and then I'll send an email to check. Is this all of the work here? Is that just in the service area? Yeah, lobby. Is there any bulb here? It's just your thing. Yeah, just use the video and recording for I'll check it out, email me whether it's right or wrong, and I'll tell you how to fix it. The reason why I did these red points is that if I just gave you that formula, it doesn't mean much, okay? The red is to tell you what's going on in the middle. What do the L's stand for? L0 up to Ln are all the little lines. L0 is the left edge, Ln is the right edge. So we'll finish the example and finally show them that. For my year 12s are going so well that they finally got an epic rant video. A little kick up the fun over the holiday, over the weekend, working a little slow. The video basically shows them that the assignment they've got 6 weeks to do, you can do on a spreadsheet in 30 minutes. The problem is what a lot of, I think because we had our discussion, I think you get it, but a lot of young people these days are like, as long as I've got my homework open in front of me, I'm doing it. That's not doing it. Doing it is doing it.
How much of this video I make that done?
Well, I kind of forced you to do service area. That's like service area volume, right? You've done half of it. You just need to write it up. Yeah. Alright, let's actually work out this area. What's 18 divided by 3? It is 6. 6 times by 10, there's no working out to do. 4 times by 25 is 100. 2 times by 30 is 60. I don't know my 38 times 10, so 4 times 38, 152. 2 times 36 is 72. 4 times 22a, I think it's 88, plus nothing. You're going to add those together on your calculator. 6 times by 10 plus 100 plus 60. 482. Times that by 6. What's going on? That's an area. What units was our lengths in? Meters, so that would be square meters. Okay. Meters, little too. Okay. Sorry. Obviously, when you're trying to draw that, I don't know, it looks like Ayers Rock or something, it doesn't need to look exactly. You just draw something that vaguely looks like a caterpillar, yeah? With the lines drawn through it. Now that ends your timeline.